Alright, what's up guys? In this video, we're going to pick up some multivariable calculus. We're going to be talking about collinear points and cross products. So we're asked to use cross products to determine if the given points A, B, and C are collinear. So they give us these points here, A, B, and C. We determine if they're collinear. So basically what you do for this is use the test for collinearity. And basically, the 3 points that we're given here, A, B, and C, are collinear. Basically, if let's say the vectors A, B, for example, would be parallel to BC, or just as a quicker statement, when we calculate the cross product of AB and BC, if it's equal to 0, then these points are collinear. If not, then they're not collinear, and that's basically the way we do it. So clearly what we need to do is get A, B, and BC from these points. Then I'll take the cross product and see what we get. Okay, so let's find AB first. We need to get our vectors. So that's just going to be B minus A. So it's going to be 5 minus 3, 4 minus 2, and looks like we'll have 7 minus 1. This will give us AB. So it looks like AB here is just going to end up being 2, 2, positive 6. Or if you want to, you can write it as 2I plus 2J plus 6K. So that's AB. We now need BC. So we need the vectors here so that we can take the cross product, because all we had at the beginning here was just points, and obviously we can't just do that. Okay, so it's going to be 9 minus 5. Looks like we'll have 8 minus 4, and then we'll have, well, looks like we'll have 19 minus 7. So that means that BC here is equal to 4, 4, well, it's going to be positive 12. And again, if you want to write that as 4I plus 4J plus 12K, that's fine too. So now we have A, B, and AC, which is our vectors, and we can use those vectors here to compute the cross product. So let's do that. So we're going to take our cross product. So we'll set up the matrix. Remember that the first row will be the unit vectors I, J, and K. Then we'll have the components of AB for our second row, components of BC for the third row. So this would be 2, or not 2, but 2, 2, and 6. And then 4, 4, and positive 12. So all we got to do is compute the cross product here. So eliminating the row and column containing I, we'll get 2, 6, 4, and 12. We'll stick an I on the outside. Then this will be minus. Eliminating the column and row containing J, we'll get 2, 6, 4, and 12. And then this will be plus. And then eliminating this row and column containing K, we're going to have 2, 2, 4, and 4. So let's go ahead and do it. So we'll obviously get 24 minus 24. We stick our I on the outside. Then this would be minus. Well, it looks like we'll get the same thing. It'll be 24 minus 24. And then over here, we'll have 8 minus 8. Okay. So clearly here, the cross product of the two vectors A, B, and BC is going to be 0I plus minus 0 j plus 0k, which is obviously is 0. Now we know that the points are collinear if the cross product of these two vectors a, b, and b, c is 0, which it is. Okay. So that means that the 3 points that they gave us are collinear. So your final answer here, when we do it, we can say that the points that they gave us, which were A, B, and C, are collinear. And we prove that by using cross products. But we know we needed to get vectors in order to do the cross product. So that's why we got the vectors that we needed, A, B, and B, C. All right, pretty straightforward, I think. So let me know if you have any questions about how I got my answer. I'll be more than happy to talk about it with you. And that's going to be it. All right, I'll see y'all next time. Y'all take care.